Once again, good afternoon. My name is Tom Sawinski. I work for the Department of Energy's Office of Advanced Reactor Technologies. I'm here today to provide you an opportunity in the NEAP RC-6 field, which deals with computational methodologies supporting the design and analysis of sodium-cooled fast reactors. I'd like to start off by beginning with the objectives of our SFR Methodologies program. The overall emphasis of this program is to develop tools to support design and analysis of sodium-cooled fast reactors, with a particular focus in the fields of reactor neutronics, thermal hydraulics, and structural performance during normal operations and during postulated accidents. By developing these tools, we'll be able to raise the technical readiness of this reactor type and support future commercial deployment. In order to meet these objectives, I'd like to go over what we're actually looking for in terms of methodologies. So two main fields I've previously spoken about is sodium fast reactor neutronics and thermal hydraulics. In the area of neutronics, we're focusing on point kinetics, which deals more with transient analysis of the reactors, neutron diffusion and transport for modeling the reactor during normal operations, and also characterization of the reactivity feedback mechanisms that are unique to sodium fast reactors and contribute to their inherent safety qualities. In terms of thermal hydraulics, we're looking at the behavior of liquid metals, especially ones that have low Prandtl numbers due to their unique heat transfer characteristics. In that field, we're looking at systems and safety analysis tools, methods for analyzing subchannels, and also looking to utilize computational fluid dynamic methods. Right now I'd like to give you an overview of some of the current activities that the Office of Advanced Reactor Technologies are pursuing in terms of sodium fast reactor methodologies. These activities can be grouped into experimental work and code development activities. For the experimental work, we're focusing on ex-vessel cooling characteristics by utilizing the natural circulation shutdown test facility at the Argonne National Laboratory. We're also archiving past data from previous tests done by former fast reactor facilities such as EBR2, Fast Flux Test Facility, and treat reactors. These will help support code validation efforts. In terms of code development activities, we are still working on enhancing the SAS4A and SAS1 systems and safety analysis codes, and also working on analyzing assessments on sodium fires under the use of the Contain LMR code, which is also being used under the Melcor code system. Now that you have an idea of some of the work that's ongoing, I'd like to present the specific topics of interest for this RC-6 work scope. We're looking for contributions to advance the development of modules in two key areas. The first deals with modeling SFR subassemblies for different fields, such as pin power reconstruction, temperature gradients, and reactivity feedback distributions. Solutions and models for these areas will aid us in analyzing steady-state thermal hydraulics and will also give us a better idea of fuel blowing and core radial expansion effects in sodium fast reactors. The second topic of interest deals with post-scram modeling and thermal stratification in large volumes of a pool-type sodium fast reactor. This will allow us to better understand natural circulation phenomena and flow rates, and will also give us insight into decay heat removal following post-scram conditions. Now I'd just like to provide an overall summary. As I've stated previously, our main goal is to develop tools to support the design and analysis of sodium fast reactors. This will raise their technical readiness and support their commercial development. I also want to point out that strong consideration is going to be given to the enhancement and validation and use and uncertainty analysis of codes and analysis capabilities currently being developed under the ARP program, such as the SAS4A, SAS1 codes, and the work being done at the NSTF. And like I stated previously, the specific topics of interest deal with modeling pin power construction, temperature gradients, reactivity feedbacks when SFR subassemblies, which will support thermal hydraulic analyses of the reactors, and also help us analyze the fuel blowing effect and radial expansions. And also under thermal hydraulics, we're looking at modeling post-scram mixing and thermal stratification, which will support analyzing decay heat removal in a pool-type sodium fast reactor. With that, I'd like to open it up for any questions.
Tom, the first question.
Okay.
You're looking specifically for Doppler effect and or reactivity feedback effects or not?
Not necessarily specifically just on the Doppler effect, but that is one of the items of reactivity feedback mechanisms which could play into the subassembly analysis portion of this call. So that's one of the small items that could play into it, not the overall objective. But yes, that's one of the things that's currently being looked at and important in general for sodium fast reactor development.
If we don't have any further questions, we'll wait about 2 minutes
Sure.
for any additional questions to come in.